In this section, we're going to review complex numbers and operations on complex numbers. Just to review, we talked about the set of complex number including the imaginary value I, and I equals the square root of -1, and I squared equals -1. When you're going to be asked to write in the standard form, the standard form is A plus BI. The imaginary part comes after your constant. So let's look at subtraction of two complex numbers. So we have 4 minus 6i minus 6 plus 2i. We're going to do this in the exact same way as we would add and subtract any variable. So we remove parentheses first. So if there's nothing in front of parentheses, we can just drop the parentheses. So this gives us 4 minus 6i. If there's a minus sign in front of parentheses, we distribute a -1 times each, which all that does is change the sign. So this becomes a -6 and a -2i. Our next step is to combine like terms. So 4 minus 6 is -2, and -6i and -2i give me a -8i. So my answer is simply -2 minus 8i, and I do have it in the standard form. Next, let's talk about addition. So again, the rules are if nothing's in front of parentheses, or if there's a plus sign in front of parentheses, you can just drop the parentheses. So for the first, nothing's in front, so we just drop the parentheses and it becomes -7 plus 3i. Since there's a plus sign in front of the second parenthesis, you can either think of that as a +1 and distribute that times both, or you can just drop the parentheses and this becomes -2 minus 7i. Your next step is to combine like terms. So we combine -7 and -2, and that gives us a -9. And then we combine +3i and -7i. So 3 minus 7 is -4i. And that would be our final answer. And again, it's in standard form. So next, we're going to incorporate this concept of I squared equaling -1 as we go through multiplication. So in multiplication, we're multiplying the quantity 3 plus 2i times the quantity 2 minus 6i. So some of you call it the FOIL method. We're going to use the FOIL method or the distributive property. So I'm going to take the +3 and multiply it times each of the terms inside parentheses. Then I'm going to take the +2i times both of the terms. So I multiply 3 times 2 and I get 6. I multiply 3 times -6i, and that gives me -18i. Next, I'm going to take the +2i times each term. So +2i times 2 is +4i, and then +2i times -6i is -12i squared. So keep in mind, I squared equals -1. So we have 6 minus 18i plus 4i minus 12 times a -1. That's 6 minus 18i plus 4i plus 12, because -12 times -1 is +12. And last, we combine like terms. So 6 plus 12 is 18, and -18i plus 4i is -14i. And again, I have it in its standard form. Let's do another multiplication problem. 5 plus 3i times -4 minus i. So we start by distributing the 5 times each term. So 5 times -4 is -20. 5 times -1i or -i gives me -5i. Next, we're going to take the 3i times both. So +3i times -4 is negative 12i, and positive 3i times negative I is negative 3i squared. So keep in mind I squared is negative 1. Then I'm going to multiply the negative 3 times negative 1. And then I'm going to combine like terms. So negative 20 plus 3 is negative 17. And negative 5i minus 12i is negative 17i. So very much the same as you've done before. Use your FOIL method or distributive property. And the only difference here is that I squared equals negative 1. So you'll be able to simplify further. Now the next one is a special type. And so you've talked about this in intermediate algebra or algebra 2. Here we're multiplying a factor times its conjugate. So this is going to come in handy when we do division. So a conjugate, remember, our terms are essentially the same. One is subtraction and one's addition. So they both have 6 and 5i, but one's separated by a minus sign and the other by a plus sign. So we're going to do this the long way, and then we're going to look at the shortcut. So doing it the long way just means that we're going to use the distributive property. So I'm going to multiply 6 times both of the terms. So 6 times 6 is 36. 6 times 5i is 30i. Next, I'm going to distribute the negative 5i times both. So negative 5i times 6 is negative 30i. And negative 5i times 5i is negative 25i squared. So keep in mind, anytime we multiplied the factor times its conjugate, our middle term was eliminated. So now I'm going to go ahead and simplify further. So remember, I squared is negative 1, so we have 36. Negative 25 times negative 1 is positive 25. And 36 plus 25 is 61. So there's two things here. Again, when we multiply a factor times its conjugate, there won't be a middle term, nor will there be an I left in the answer. So our answer will be a rational number always. So what's the shortcut? So if you look at what we got in our final answer, if our middle term is eliminated, all we really need to do, once we've identified factors as being conjugates of one another, is to multiply the first two terms together. So if you look at the previous example, if you multiply 6 times 6, you got 36. Then if you multiply negative 5i times positive 5i, you got negative 25i squared, or negative 25 times negative 1. So let's just go and do the shortcut on this problem. So again, they're conjugates because they're both 3 and 2i. One's separated by a plus sign, the other by a minus. So all we have to do is multiply the first two terms together. So 3 times 3 is 9. 2i times negative 2i is negative 4i squared. So I squared is negative 1. Negative 4 times negative 1 is positive 4. So our answer for this particular problem is simply 13. Very easy to do once you become comfortable with the shortcut and why you would use the shortcut. So now let's talk about division. So in division, as you've discussed in the past, we can't have a radical in the denominator. So remember that I is a radical. I is the square root of negative 1. So we have to remove the I from the denominator. So what process are we going to use? We're going to multiply, if it's a binomial, in this case it's a binomial because it has two terms, and I'm going to put that in parentheses. If we multiply a binomial times its conjugate, then we'll end up with a rational denominator. So this process is called rationalizing. So I'm going to multiply numerator and denominator by the conjugate of the denominator. Conjugate means, again, the terms are essentially the same, except for one's a plus and one's a minus. So in the numerator, I'm going to use the distributive property. So I'm going to multiply 9 times 3, and then 9 times minus I. In the denominator, I'm going to use the shortcut because I know there's not going to be a middle term. So I multiply 3 times 3, I get 9, and positive I times negative I is negative I squared. So in the numerator, I have 27 minus 9I. In the denominator, I have 9 plus 1. Because I squared is a negative 1, so you essentially have 9 minus a negative 1, so you have a double negative here, which makes it positive. So we'd have 27 minus 9I over 10. Now, if we want to write it in the standard form, we want to separate this into two fractions. So this would be 27 over 10 minus 9 over 10I. You would reduce at this stage if you could. So let's look at another one. In this case, we have 5 plus 4I over 8 minus 7I. So again, what I like to do, anytime I'm dealing with binomials, I like to put them in parentheses. So if I'm dividing, remember I need to rationalize the denominator. So I need to multiply numerator and denominator by the conjugate of the denominator. So the conjugate would be 8 plus 7I. In the numerator, I have to use the distributive property in its entirety. So I have to do 5 times 8 and 7I, then 4I times both. So I start by multiplying 5 times 8, and I get 40. 5 times 7I, I get 35I. 4I times 8, which is 32I. And then 4I times 7I, which is 28I squared. So again, you're going to take each term, the 5 times the 8 plus 7I, then the positive 4I times the 8 plus 7I. In the denominator, we can use the shortcut because we're multiplying a factor times its conjugate. So 8 times 8 is 64, minus a negative 7I times a positive 7I is a 49I squared. So anywhere I have an I squared, remember that would be a negative 1. So in the numerator, I have 40 plus 35I plus 32I. And here I have 28, positive 28 times negative 1, which is a negative 28. In the denominator, I have 64, and I'd have a negative 49 times a negative 1, which is a positive 49. Next, combine your like terms. So in the numerator, I have 40 minus 28, which is 12. I have 35 plus 32, which is 67I. And in the denominator, 64 plus 49, I get 113. My last step is to write it in standard form. So I'd have 12 over 113 plus 67 over 113I. Let's try one last one. So we have 6 minus 5I over 6 plus 3I. Again, I'm dealing with binomials, so I'm going to put them inside parentheses. I want to rationalize, so I need to multiply by the conjugate of the denominator. Notice the signs are opposite, one's plus, one's minus. Next, I want to use the distributive property in the numerator. So I multiply 6 times both terms, then negative 5I times both terms. So 6 times 6 is 36. 6 times negative 3I is negative 18I. Then I multiply negative 5I times both, and this gives me negative 30I. And negative 5I times negative 3I is positive 15I squared. In the denominator, shortcut. All I have to do is multiply the first two together. So 6 times 6 is 36. And positive 3i times negative 3i gives me negative 9i squared. Keep in mind again, I squared is negative 1. So in the denominator, this would change to 36. Negative 9 times negative 1 is positive 9. And in the numerator, 15i squared, that's 15 times negative 1, which would give me a negative 15. So now, combine like terms. 36 minus 15 is 21. Negative 18i minus 30i is negative 48i. 36 plus 9 is 45. I need to write it in standard form. So I have 21 over 45 minus 48 over 45i. Now I can reduce. 3 goes into both 21 and 45, so this becomes 7 over 15. And 3 also divides into 48 and 45, so 48 divided by 3 is 16, 45 divided by 3 is 15. So my final answer in standard form would be 7 over 15 minus 16 over 15i.